Dear students, now we are going to discuss about counting of numbers. Do you all know what is numbers? Numbers play an important role in mathematics. Counting things is easy for us now. We can count objects in large numbers. For example, the number of students in the school and represent them through numbers. We can also communicate large numbers using suitable number names. Many thousand years ago, people know only small numbers. Gradually, they learned how to handle large numbers. They also learned how to express large numbers in symbols. All this came through collective efforts of human beings. Their path was not easy. They struggled all along the way. In fact, the development of whole of the mathematics can be understood this way. As human beings progressed, there were greater need for development of mathematics, and as a result, mathematics grew further and faster. We use numbers and know many things about them. Numbers helps us count concrete objects. They help us to say which collection of objects is bigger and arrange them in order. For example, first, second and so on. Numbers are used in many different contexts and in many ways. Think about various situations where we use numbers. We have added, subtracted, multiplied and divided them. We also looked for patterns in number sequence and done many interesting things with numbers. In this chapter, we shall move forward on such interesting things with a bit of review and revision as well. Children learn to count before they learn to write numbers, just as they learn to speak before they learn to write the number name. Children begin school with a variety of experience. Indeed, the range of mathematical skills and understanding in earlier years. Classroom can be quite vast. Children arriving for their first year of school may be able to recite the numbers up to 20 in order, write the numerals 0 to 9, grasp the connection between the numeral 3, the number name 3 and a picture 3. Numeracy and literacy are essential skills in modern society. Just as we need a notation to write down words, we use a base 10 place value notations to write numbers. It was developed over several centuries in India and Arab world. So, we call it Hindu-Arabic notation. The place value nature of Hindu-Arabian notation enabled the development of highly efficient algorithms for arithmetic, and this contributed to its success and wide acceptance. Hindu-Arabic numerals exhibit some of the quantities that make mathematics so powerful. Namely, they can be used by understanding a small number of ideas. They can be generalized beyond the original setting for which they were devised. To illustrate the second point, the notation was developed to express whole numbers, but it extends to the representation of fractions and decimals. A solid understanding of numbers and arithmetic is essential for the development of later concepts including fractions and algebra. Even a 10th standard student do not know the fundamental rules of the mathematics. If they need to acquire knowledge in mathematics, they must know the fundamental concepts in mathematics. Now coming to the content, Hindu-Arabic numerals are a decimal or base 10 place value system with the 10 digits 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9 as fundamental building blocks. It is important that students build an understanding of the numbers up to 10 before they progress further. Now let us see counting. The numbers used by us in our daily life are written using symbols 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. These are known as digits, and this number system is called the Hindu-Arabic number system. This collection of numbers is called the counting numbers, and it is also called as natural numbers. The smallest counting number or natural number is 1. There is no greatest natural number, as the set of natural numbers extends infinitely. Natural number n is equal to 1, 2, 3, etc. I have already mentioned that the natural numbers and counting numbers are the same. If 0 is included, it becomes the set of whole numbers and it is represented by W. Whole number W is equal to 0, 1, 2, 3, etc. Thus, 0 is the smallest whole number. Every natural number is a whole number, but 0 is a whole number which is not a natural number. Now coming to number line. A line with numbers placed in their correct position is useful for addition, subtraction and for showing relations between numbers. Example for counting numbers. Do you all see which of the following is not a counting number? Yes, 0 is not a counting number. Teachers can give worksheets to the students and help them practice counting in a most effective way. Now the next is pre-counting. Let us see the difference between number and numeral. A number is an abstract concept. For example, 3 pens, 3 chairs, 3 bicycles, etc. Whereas the symbol 3 and the Roman letter are numerals for the number 3. For example, the numeral 3 relates directly to the number of stars as shown here. The concept of number is universal. The number names and numerals are necessary but arbitrarily label invented by humans. Some students may have a good sense of number from an early age. They all need to learn the number names and numerals. Now let us see an example. Express the following numbers in words. Can you able to answer it? Yes, it is 2576. Can you express this? Yes, 6049. Now let us see subitizing. Subitizing is a term that was coined by the theorist Piaget, first psychologist, and he defined the ability to instantaneously recognize the number of objects in small group without the need to count. Young children particularly enjoy the physical manipulation of objects. Now, by asking key questions such as, can you see the figure? Can you see how many flowers do you see inside the box? Do you know how many apples are in the bowl? Now coming to one-to-one correspondence. Before learning to count, a child needs to understand one-to-one correspondence. This means being able to match one object to the another object or to a person. First year birthday baby can make judgments about the relative sizes of set of objects. They react differently when two sets of the same size are presented compared to when two sets with different amounts are presented. For example, can you see this figure? Here we have arranged some apples and balls in the same size but in different amount. In the example, it is not easy to immediately say if there are more apples or balls, but the answer is clear when they are lined up with one-to-one correspondence. Yes, you are absolutely correct. The balls are 6 and apples are 5. Matching activities will help a young child to develop one-to-one correspondence. Now let us see how to extend counting. Children who have developed the ability to count should continue to do so, expanding their range beyond 10 or 100 or 1000. Counting forwards and backwards from different starting point, including 0, helps fluency with numbers, is connected to arithmetic and can be used with fractions and decimals. Now let us see how to count backwards. Counting backwards from 20. Number train game for counting backward. Counting backward is an essential skill. Children who can count down with confidence have clearly gone beyond the basic standards. Now let us see what do you mean by skip counting. If you are not sure what skip counting is, think about counting by 5s or 2s or 10s. Now think about counting by 7s or 12s. Now think about counting backwards from 120 by 4s. Skip counting is critical to have a great number sense. It develops fluency in calculation and it serves as the basic skill of multiplication and division. Here there are few games and teaching ideas to encourage skip counting. Now let us see what do you mean by bus. The leader announces starting number and finishing number and which number will be bus. For example, we might start at 1, finish at 100 and say bus on numbers that are multiples of 5. Students can stand in a circle to count in turn by ones, but they say bus instead of specified numbers. Can we see one example? A correct sequence would be 1, 2, 3, 4 bus, 6, 7, 8, 9 bus, 11, 12 and so on. This is called as bus game. If a student forgets to bus, they are out of the game. Last one standing wins the game. Now let us see what do you mean by whisper counting. Whisper counting is a precursor to the skip counting. Can we see one example? This is an activity which assists children to move from oral counting by ones to skip counting. When counting from its starting number to the finishing number, the children whisper the numbers that are not part of the count and say loudly the numbers that are part of the count. Can we see one example? If counting by 2s, the children would whisper the odd numbers and say loudly the even numbers. The teacher and the child each take a role in counting together. Start by taking turns to count. I say 1, you say 2, I say 3, you say 4 and so on. For example, initially record all the numbers from 2 to 20, that is 2, 3, 4 and so on up to 20. Have your child circle the numbers that are part of counting by 2s starting with 2, that is 2, 4, 6, 8, 10, 12, 14, 16, 18 and 20. Starting, finishing and counting sequences can be changed according to the needs of your children. Using the 100 grid for counting. Using red color to mark count by 2s, blue color to mark the count by 5s. Use green color to mark count by 10s. Now let us see formation of numbers. In formation of numbers, we will learn the numbers having different number of objects. We know that Greatest number of one digit is 9, smallest number of two digit is 10, that is if 1 is added to 9 we will get 10. Greatest number of two digit is 99 and the smallest number of three digit is 100, that is 1 is added to 99. Greatest number of three digit is 999, the smallest number of four digit is 1000 if 1 is added to 999. Greatest number of four digit is 9999, the smallest number of five digit is 10,000, that is 1 is added to 9999. Now we will see expanded notation. Expanded notation of a number is when a number is expressed in terms of the place values of all the digits which the number consists of. We have seen how the number 6250 is formed. In expanded notation, it is written as 6000 plus 200 plus 50 plus 0. In standard notation, it is written as 4000 plus 900 plus 5 is equal to 4905. Now, we will see about comparing numbers. In that, we are going to see first the order of numbers in the number system. When two different numbers are given, there can be only one possibility. Either one of the number is greater than the other, or you can state that one of the number is smaller than the other. Two different numbers can never have the same value and thus be equal. Comparing numbers have different number of digits, that is, the greater the number of digits, the greater the number. First example, can you see 3750 is greater than 950. The next we will see 1920, is it greater than or smaller than to 920? Can you able to answer it? Yes, you are correct. 1920 is always greater than 920. Then the next thing we are going to see is comparing numbers having the same number of digits. Starting from the left and compare the digits until you find two digits that are different. Compare them to decide which is the smaller or the greater number. The first example is 19,442. Can it be greater than or equal to 19,452? Yes, you are all correct. 19,442 is always less than 19,452. We will see another example, 82,706. Will it be equal or greater or smaller than 82,076? Can you able to answer it? Yes, you are all correct. 82,706 is greater than 82,076. Now let us see how to arrange numbers. We know while arranging numbers from the smallest number to the largest number, then the numbers are arranged in ascending order. While arranging numbers from the largest number to the smallest number, then the numbers are arranged in descending order. Now we will see about successor. Can you know what do you mean by successor? Successor of a number is the number obtained by adding 1 to the number. Can you see the successor of 1000? Yes, successor of 1000 is equal to 1000 plus 1 is equal to 1001. Can we see about predecessor? What do you mean by predecessor? Predecessor of a number is the number obtained by subtracting 1 from the number. Can you tell what is the predecessor of 1000? Predecessor of 1000 is equal to 1000 minus 1 is equal to 999. Can we see how to build numbers? By arranging the digits in descending order, you can build the greatest number. By arranging the digits in ascending order, you can build the smallest number. Use 4, 8, 3, 6 and 1 to build the greatest and smallest 5-digit numbers. Can you able to build? Yes, 86,431 is the greatest number and 13,468 is the smallest number. Now let us see about even numbers. Any integer that can be divided exactly by 2, the last digit is 0, 2, 4, 6 or 8. Can you able to tell? Is 24, 0 and 38 or even numbers? Yes, you are all correct. 24, 0 and 38 are all even numbers. Now let us see about odd numbers. Like even numbers, if any integer that cannot be divided exactly by 2 is an odd number. The last digit is 1, 3, 5, 7 or 9. Odd numbers are in between the even numbers. Now let us see about prime and composite numbers. A prime number can be divided evenly only by 1 or itself, and it must be a whole number greater than 1. For example, 7 can only be divided evenly by 1 or 7. So, it is a prime number. If you see 6, it cannot be evenly divided and it will be divided by 1, 2, 3 and 6. So, it is not a prime number, it is only a composite number. Why? Because it can be divided evenly by numbers other than 1. That is, we can multiply 1 into 6, we will get 6. If we multiply 2 into 3, we will get 6. If we multiply 3 into 2, we will get 6. So, 6 is only a composite number. Can you tell what about 1? 1 is not prime and also not a composite number. Now, we will see about how to round numbers and we are going to see its rules. A number is rounded down to the nearest 10 if the ones digit is 4 or less. A number is rounded up to the nearest 10 if its ones digit is 5 or more. Find between which two tens the number lies. Round the closest 10. A number at the midway point is always rounded up to next large number. For example, 42 is rounded down to 40, but 47 is only rounded up to 50. Then what about 45? 45 is midway, so it is rounded up to 50. In this way, we have to round to the nearest 100. We are going to round 332 to the nearest 100. Can we? 332 is between 300 and 400, but 332 is very closer to 300. Therefore, 332 is rounded down to 300. Ordering and sequencing number is given to the students by the way of mental max. Now, we will see the stable order principle. To count accurately and reliably, it is very important to say the number names in the right order without skipping any numbers. The ability to assign the number names in order to objects being counted and without skipping any numbers. It is known as the stable order principle. Children may begin to do this by counting their fingers, counting the number of sleeps until their birthday or the number of peas left on their plate. This principle means that the list of words used must be in the same repeatable order. For example, it is always 1, 2, 3, 4, 5 and not 1, 2, 4, 5, 3. The name tags or number tags are always used in the same order only. Now, we will see about cardinal numbers. Do you know what do you mean by cardinal numbers? The term cardinality refers to the numbers of cardinal, that is basic numbers in a set. Cardinality can be finite, that is a non-negative integer, or infinite. For example, the cardinality of a set of people in the United States is approximately 270 million, that is international system. The cardinality of the set of integers is denumerable infinite. In the tables, the number of rows, that is also called as tuples, is called the cardinality. In practice, table always have positive integer cardinality. Table with no rows cannot exist. In theory, however, denumerable infinite cardinality can exist. An example is a multiplication table of non-negative integer in which entries are implied for all positive values, that is 0, 1, 2, 3 etc., 1, 1, 2, 3 etc., 2, 2, 4, 6 etc., 3, 3, 6, 9 etc. And then we give the activity for cardinal numbers to the students. Now we will see about 0. In mathematics, 0 is symbolized by the numeric character 0. In a positional number system, a place indicator meaning no units of this position or place. For example, 5041, we will see 5, there is 5 units in the 1000 place. In 0, no units in the 100 position. 4, 4 units in the tens position. 1, 1 units in the ones position. An independent value midway between +1 and -1 on the number line is represented as 0. If we add or subtract 0 to any number, the answer remains the same. For example, if we add 0 with 5, we will get 5, and if we subtract 0 with 5, we will get 5. Now we will see a definition and example of part whole. What do you mean by part whole? Part whole is a ratio or fraction that represents a relation between the part and its whole. We will see part whole. 5 part plus 4 part is equal to the whole 9. We will show it with an example. Suppose a bag contains 4 apples, 8 bananas and 12 oranges. Then the part whole ratio of apple is 4 divided by 24, that is equal to 1 by 6. Then we will see part whole ratio of banana is 8 divided by 24, which is equal to 1 by 3, and part whole ratio of oranges is 12 divided by 24, which is equal to 1 by 2. The teachers can give this activity by showing his fingers and ask the child to show 7 on their hands. There are many ways to do this, and soon they will see that 7 is made up of 3 and 4 and 5 and 2. Now coming to the conclusion, this mathematical system is followed by our Indian education system. These are all basic concepts to help the students to get knowledge in mathematics. Teachers are recommended to follow classroom activity and to allocate some marks for that. This method helps the students to develop their creativity power in mathematics. I hope you all enjoyed this session. Thank you.